Fulcrum One has many different simulation modes. In order to get the most out of the software, you're going to need to set up what are called environments. Environments inside the Fulcrum One software define the acoustic characteristics that wrap your loudspeaker design. To get started, let's jump in and click on the Acoustics tab here on the left-hand side. Every project file comes with a default environment to help you get started. As you import SketchUp models or CAD files, they're going to automatically attach to that default environment. In this project file, I've already brought in a room model via SketchUp and defined a loudspeaker layout for this tutorial. Let's click on the default environment here to view more. On the right-hand side on our Properties tab, we can see some preliminary stats that tell us what this environment is doing acoustically. The first option that you want to look at here is our visible objects. With environments, you're going to be able to set up multiple environments and import multiple room models if you need to. That's helpful if, for instance, you have a stadium that has a retractable roof. You could bring in a room model for the stadium with the roof open and a model for the stadium with the roof closed. Same if you're in a convention center and you have ballrooms that join and separate with a divider wall. You could have a model with a single room versus a model where the divider wall is open and there's multiple rooms attached. So under the visible objects is where you're going to actually say, when this environment is active, what do I want to see on the screen geometry wise? So in this case, we have our new theater selected. And then let's jump down now to where the acoustics are calculated. So under acoustics, we have our acoustic model selection here. That defaults to visible objects, meaning whatever's been selected up here will be used for calculating acoustics. There are certain cases where you might bring in a CAD file or a models that say only has a surface and a stage and isn't a complete model that you could actually generate acoustic stats on. So in that case, you may want to switch over to cuboid, which essentially puts a theoretical room around whatever visible objects you have. So you can define that via length, width, and height or volume, and it'll automatically set the length, width, and height based on the golden rule. You also have the option here to offset that cuboid around. For this tutorial, we're going to actually stick with visible objects since our room model is built to calculate acoustics. The next option down is our calculation mode. So once we've told the environment engine what model to use, we need to tell it how to calculate the acoustics. And that can be done either by materials that we paint onto all the surfaces or via a fixed RT that we can define here by editing the reverberation time and moving at each frequency the dots here depending on the timing values that we want. You can also choose from a preset list too if you desire. For this example, we're going to use the default mode, which is materials. The final option here we have is noise level. And noise level comes into play in certain mapping modes like total SPL or STI. For this, I just have a simple RC30 specified, but you can edit that just like the RT chart. Let's jump over to the materials here and talk through how to apply those materials to the surfaces. On the left-hand sidebar here, you can see that I've already brought in some materials for us to use. But you can add your own by just clicking the plus sign here and hitting new, or you can choose from library, which we have a whole entire list of items that you can bring in. Let's go ahead and select our walls here, our walls material, and we can apply that to the surfaces just by clicking the paint and painting on each individual face, or while the paint brush is active, we can also just click the walls here. Now, for this tutorial, I'm just going to keep it simple and also paint that, and let's also do the ceiling as well. So we've got some surfaces painted. Let's switch over to the floors, and we'll do the aisles and the stage with that. And then for this one, let's do the audience as the seating. Now, my audience material is actually simulating occupied seats, so people sitting in seats. This is where the environment engine gets super powerful. Let's go ahead and create another environment here, and we'll call this one unoccupied. And we'll call the first one occupied. Now, when I created this new environment, you can see here that it is just a duplicate of whatever environment was active. To switch over to that, I'm going to click the little symbol here on the left-hand side, this little box. I can also choose from the drop-down menu over here. Now in this environment, I'm going to go ahead and choose our empty seats, click the paintbrush here, and paint our seating. And now I can see here that we have some differences between the two environments. To better visualize that, we can actually open up the acoustic stats menu here and take a look at the reverberation time between the two environments. Let's jump over to the mapping tab and take a look at how the environments now correlate right into the mapping modes. So under mapping, I have a mode here called direct reverberant ratio, and I can switch on the right side here, the environment, to view how that acoustic energy changes the mapping of the loudspeaker system. Environments are also taken into account with other modes like total SPL, signal noise ratio, and STI. If you don't have certain properties set up, then you'll get a warning like this one we see here with the signal noise ratio and STI. This warning is telling us that we haven't specified a noise level for this active environment. We click on this, we can see that in our unoccupied, I need to go ahead and set a noise level. Let's go ahead and set that to RC30 and hit done. And now we can see that those warnings are gone and we can properly view the STI value for this environment that we're currently in, which is the unoccupied. So in the unoccupied, we're good, and up at the top, we're excellent. Let's switch over to the occupied and see how that chart changes. This is where we can play around with the acoustic materials and our loudspeaker design, along with the environment, to get a more complete picture throughout all the simulation modes. If you'd like more information, check out our support site at support.fulcrum-acoustic.com.